Hi, this will be a short discussion on math and circles. So it won't be exhaustive, but it'll just be sort of a short intro to, the math of drawing things with circles on the screen, okay? Just to give you an idea of like why you might want to understand this math, I'm going to show a couple examples here. These are some, this is just a page with some sample iOS apps from 2015. And there's a app here called Keezy. I don't even know what this app does, but you can see they've got a menu in a circle, and all the little items here are drawn as a circle. You can see the animation kind of spins, right? Okay. So, you might want to arrange these buttons in a circle there. There's another app here, Tumblr, right? So let me look at this is a little weird there. I don't know what's going on there, but they have a circle menu. Let me rewind that, see if I can rewind to the beginning there. Yeah, there we go, right? So you can see all the buttons at the very beginning there. They kind of arrange themselves in a circle, and then they kind of come out from the center, right? So might want to be able to do that in code, depending on how many buttons you have, always make them arrange themselves in a circle. And then here's a startup screen from, the Android app, right? And there's this might not be an interface, but there's a lot of circles going on there, right? And they needed to calculate all that stuff. So anyway, there's just a couple examples, and there's a bunch more you can find. I've seen a lot of apps use this. So, how does it work, right? Let's take a look. So I have some notes here, right? Okay, so imagine you have a circle, right? And a lot of times, we look at a circle and we talk about it in terms of degrees. So, there's 360 degrees in a circle. So if you started at 0 and you went all the way around the circle back to the beginning, that would be 360 degrees, okay? On the computer, most of the time, circles are measured in radians. So, if you started here and then you went all the way around the circle, you would come back to the beginning at 2 pi. Okay, that would be radians. Okay, so 2 pi. So pi is, 3.14. So essentially, we could look at the circle like this in this term, right? We could say 6.28, right? That's like 3.14. I mean, that's a little inaccurate because pi has a few more decimal places, but in generally speaking, like we could look at the circle in radians as 360 degrees in radians. It's the same thing as saying 6.28. Okay. So what else can we look at the circle, or how else can we look at the circle, right? If we have a value in radians, we can use sine and cosine to map an XY coordinate around the outside. So, you'll realize, like, if we have a center point here and then we want to place an object somewhere along the circle here, essentially the screen isn't mapped out in radial coordinates. It's mapped out in a grid. So there's, pixels in rows and columns here, and they don't map directly to our circle in degrees, right? So what we can do is, if we have a circle, we can use sine to calculate the x. I think actually maybe I have this backwards. Maybe sine's supposed to be the y, but actually it doesn't matter in practice. You can use one or the other, right? So sine, for me, is going to provide an x value, and cosine is going to provide a y value, right? So now, just so you understand, sine is a function, just like any function you might write. It takes a number in and returns to you a value between -1 and +1. Okay, so if you put any number in here, let's call that number t, right? Then sine is going to return -1 to +1, depending on what the t value is. Okay, and if you kept plugging numbers in, like if you put in the number, t, and it was like 0.1 and then 0.2 and 0.3, then slowly the numbers would move from +1 to -1, and then back to +1, and through 0 to -1, and they would keep going back and forth forever. Okay, and the same is true for cosine, right? So cosine for any value is going to give us a number between +1 and -1. Okay? So, so how does that work? Well, essentially, we can use the cosine and sine values, like the values returned from them, if we plug the same number into both, to map out an x-coordinate and a y-coordinate that goes around the circle, right? So that's a little, it might seem a little abstract. Let me kind of explain it here with some numbers, right? So let's imagine you have a value of t that's 5.2. If 6.28 was the entire circle here, 5.2 might end up here. Actually, I maybe have the arrow going the wrong way there, but like if we go around like this and we get to here, that might be 5.2. And then sine might return a number of, negative 0.86, right? And you can see if I draw a line up to here, that's not quite -1, negative 0.86 might be right about here, right? And then cosine might be 0.49. So, if I line that up here, 0.49 might be about halfway down the line there, right? And those two numbers together would map out to this point right here where this line crosses the outer line, okay? So that's pretty good. And then you're thinking like, well, okay, well, if you're thinking about this really, like, this is only 1 pixel, right? So like, if we counted these as pixels, right, our object on the screen would it could move 3 pixels, right? It could be like +1, 0, -1. If you notice, I'm barely moving the cursor, right? So that doesn't really work. So what we need to do is we need to multiply this value times the radius of the circle, right? So let's take another look over here, right? So let's imagine that the radius of our circle is 120, okay, 120 points, right? So if we took the t value of, 5.2, right, and then we plugged it into sine, and sine gave us negative 0.86, and we multiplied that times 120, we would get -100. Right, so that's a pretty sizable amount of pixels, right? So we'd see that on the screen for sure. And then if we took the 0.49 value that we got plugging, 5.2 into cosine, that would give us 59 pixels, right? So now our object would be, -100 pixels on the x and +59 pixels on the y, okay? Now realize though that these numbers aren't very good because they're not perfect. They're close, right? Because essentially, like if I draw a rectangle here that represents the screen of our iPhone, right? Our iPhone would fall in this coordinate space here, and so the -100 would move our object off the screen, and we would only see the object in the arc that fell right here, right? So this doesn't quite work for us. We still have to do one more step, right? So we've got sine and cosine working for us, in abstract, right? You plug some number in here, it returns an x value for sine that is -1 to +1. We can multiply times the radius of our circle, right? Okay, but then our numbers are going to go negative the radius to positive the radius on the x, and negative the radius, positive the radius on y. So what we need to do is we need to offset the whole thing. So imagine that this was our iPhone screen and we wanted to draw a circle in the middle of the screen, right? So if I zoom in on this, you can see like this is the center of the screen here, right? This is our phone. There's the center. So the center point is 187.5x and 333.5 on the y, right? So that means that we'd have to take the -100 on the x, right, and add that or add 187 to it. Actually, my numbers are not quite matching here, but essentially that would give us something like 87.5, right? And then if we took the 333 and added the 59 to it, we'd get 380 something or 390 something, right? And that would be the number here, right? So that would be our position here. So like, if we look at this, we're mapping around the circle there, and then we're offsetting the circle from the corner here to move it down into the center of the screen, and then mapping around that center. Okay, so anyway, I hope that kind of explains a little bit of this, and then in the next video we'll do an example in code where we actually take some objects and then place them around a circle on an actual iPhone screen, and then we can animate them in a circle also. So anyway, thanks for watching, and then I hope that is a refresher for anybody that is shaky on their sine and cosine math stuff. Okay, so anyway, thanks for watching.